Hi everyone, welcome back, and today I'm gonna show you my first project, which is with my Creality K2 Plus here, and it is building these contraptions right here. Now, just a little bit of background. The Creality K2 Plus has carbon filters, so these are great for VOCs, removing VOCs. I mean, basically those are the smells that you get, volatile organic compounds. There's a bit of it. I don't think it's too much of a concern, but it's a great thing that the machine does come with the carbon filters. And those are inside and normally last for quite some time. I would say probably from what I've seen about anywhere between, depending on what you're printing, of course. If you're printing ABS and PETG, maybe will last less than PLAs, but essentially it does run for probably up to 500 hours, I would say is minimal. But it does not come with HEPA filters. So I created this adaptation here, and I'll show you a little bit the logic behind it and how to create these. Now the HEPA filters, this was built quite tight, as you can see, and it's got magnets, which is the simple way of adapting this here. Now these are ceramic magnets, and of course you can use any type of magnets. Neodymium magnets would be even more powerful. This filter, first things first, by the way, this filter, from what I understand, if I research it, just basic AI research, it lasts anywhere between 200 to, I would say, 6, maybe even 700 hours would be pushing it. But because these are quite cheap, they come 3 in a pack. This is a model called MCV194H. And essentially, these are good. The HEPA filters, the whole logic behind it is that it prevents dust from going into your environment. So it's kind of a dust blocker. The idea here is to first take measurements. So there's 2 exhaust parts where the dust comes from. The middle one is a fan that regulates the heat from the machine, but the 2 corner ones are where the the carbon filters are. And the idea behind it is, first and foremost, I took measurements. So just used a regular digital caliper to just take the measurements and sort of have an idea of what type of size do I need for the HEPA filter. Now, once you have an idea of the size, basically the what the length would be, what the height would be, you kind of have to research it on Amazon. And excuse me, the one that I found that was the closest was this model right here. No worries, because I will have all the details and the links in this episode. Now, once I did get the closest possible fitting model, ideally the best way to do this is to check what the measurements are on Amazon, because those are, or wherever you're buying it from, because those are the closest measurements that will give you the length, the height, the width. Now, ideally here is that once you have all that, you could, and by the way, the magnets, these are regular the ceramic magnets, and once you have the size of your filter and the magnets, you want to create an encasing. Now the magnets don't need to be cylindrical. These are cylindrical magnets, as you can see. I will have the exact model of it, but these could be square. There's also tape around magnets, so you could just tape it around. But ideally, once you have the measurements, so this here would be this is my length, but if I wanted to put it this way, then this would be my length. So this is my length, obviously the height and the width. Now, if we want to look at it from the point of view of AutoCAD or just a CAD system, I use FreeCAD, and I'll explain why. Because it's so good with Python. So ideally, looking at it from a different perspective, which is the design mode, the length is actually your x-axis, the width is your y-axis, and the height would be your z-axis. So, to get back to the basics here, once you have your length, you need to decide if you're going to put it this way or this way. I decided to put it this way, obviously. It is better. So this becomes my length, this becomes my height, and of course we have the width. Now, I'm going to have a full episode showing you exactly how I built this in FreeCAD manually. Of course, just a little bit of a hint is that you could actually use Python. You could just ask AI, prompt it based on the measurements for the Python code to create it, and you could just paste and input it in FreeCAD, and as simple as that, it will create the model for you, ready to print. For the magnet, all you need is the height. So again, use your caliper, get the height, and basically the length of it. So half of the length would be the radius, and that is all you need, just height and radius. Now, once you've got that, basically you're going to be able to just transfer everything in FreeCAD, and essentially I decided to add a 1 millimeter here just to protect it so it doesn't scratch the unit, and it doesn't just smack right into it too much. So just a little protective there. But once all these details are in, you could just use AI, prompt it, it will give you the specs, and you could decide to prompt AI to provide you how to manually design it in FreeCAD, step by step, or you could just ask AI to provide you with the full Python code that you will copy, paste, and FreeCAD will just design it in basically just under 3 seconds, flat. Now, as you can see, this is a very tight unit. And again, I'm going to explain on the next episode while I show you how to create it in FreeCAD. And I'll show you how to create it manually in FreeCAD, as well as how to use code, which is very simple. But as you can see, it fits really tight in here. And just going to push it in. And this is what you want. You want a very tight fit. Now, there's a couple of things that I really wanted to do, which were a variation of this. And one of those variations was to actually have a lisp that goes in the back. That way you can't you wouldn't have to concern yourself too much with having a very tight fit. So if you have a lisp, it will just prevent it from falling backwards, although this is not powerful enough to push it out. So is a lisp really needed? No, but I really wanted the tight fit. There is a problem, however, with the tight fit. Let me explain. Sometimes it is too tight, and other times it is a bit too loose. So I had created various prototypes that I had to play around with. And the reason is the gap. You can't really have the perfect gap from start, because we're talking about 0.0 millimeters here. And trying to get the right tightness around this in terms of gaps is tricky, and you'll probably have to do a few different tests, and this is one of them that I've done. As you can see, it's much shorter in the width, and that's because I didn't want to lose a lot of filler. And yes, this is the filler that usually comes in, that you need to essentially just knock it out. These are held by columns in order for the filament to be properly deposited in a roundabout fashion. And there are also the fillers in here. So once I show you how to prototype this in FreeCAD, you'll be able to understand the why I've created a thicker, like this here's a 2 millimeter thickness, but as you can see, the new models are a lot thicker. And the reason is you're gonna have to scrape a bit using a sharp scraper. Just be careful not to ruin your hands, not to stab yourself with it. But the idea behind the magnets is because I really wanted to have a very tight fit. So again, you'll just need to just scrape a bit of the roundabout, because these fit really. The these cylindrical bosses are very tight, and essentially that's what I wanted. And I think that this came out really well. I'm not going to use this for more than 100 hours, just simply because this pack was really cheap. It's about $15 Canadian, so it will run much cheaper in American. And yeah, I'm really happy with these. It's gonna, of course, it's a bit of overkill in my personal opinion. You could, of course, just get yourself a filter that also has not just the HEPA, but this is a Levoit filter, by the way, but it also has the HEPA filter. It has the HEPA filter and the carbon filter in here for VOCs. Put it 2 feet away, put it on full blast, and you're good to go. I think these are a bit overkill, so really not necessary, but nonetheless, I enjoyed going through the experimentation, and really enjoyed going through this, the whole scope of it, which is the design part, the printing part, getting to know my machine a bit better, and really enjoyed the journey. By the way, just to finish up, these are printed with PLA. Not ideal. PETG is a stronger plastic and probably better suited for this. I think ABS is overkill. Yeah, I don't recommend ABS for it. Of course, if you want to print it in ABS, that's perfect, but just know that it'll be harder to scrape the inside of the bores here, the empty cylinders. But yeah, it's perfect. I do love the model. Lock it in that way, and again, there's not too much heat coming out of here. In fact, I haven't detected a lot of heat at all, and because normally PLA might warp with long-term exposure to heat, but these should be perfectly fine with the PLA filament. That's pretty much it. I do hope that you enjoyed the session. This was my first print, my first experimentation with 3D printing. I have not experimented before, and I'm kind of new to this, and I hope to get a lot of mileage and a lot of projects coming up, and I hope that you enjoy those projects. Please like and subscribe. I hope you enjoy this channel, and there's a lot more coming. Thanks for watching, and bye for now.